Hi, today we're going to discuss about fractions and decimals. We will establish the relationship between fractions and decimal. Are all fractions can be changed to decimals or are all decimals can be changed to fractions? Please join me as we go along with this lesson. So are you ready guys? Let's go. And the learning objectives includes first, express fractions to decimals. Second, express decimals to fractions. Third, express non-terminating decimals to fractions. In our previous lesson, we discussed about the definition of rational number. We said that a rational number is any number that can be written as P over Q, where P is not equal to 0, or it is written as fraction. But we have another definition. Rational number is a number represented by either terminating or repeating non-terminating decimal. Okay, so we have an example for terminating decimal. 0.25, it terminates. 5.27341, it terminates. Okay, so this is an example of terminating decimal. We have 0.33333 and so on and so forth, or dot dot dot. Okay, so the three dots, meaning to say the digits repeats. Okay, okay. So we have 1.012 dot dot dot. So meaning the repeated digits are 012. Okay, 012, and so on and so forth. Next example is 0.125, and so on and so forth. So meaning the bar above 125, it tells us that the digit 125, the digits 125 keeps on repeating. Okay, so another example is 0.4444. Okay, so meaning the digit 4 repeats. Okay, so it does not terminate. All right, so this is an example of repeating non-terminating decimal. Example number 1, express 3/4 as decimal. All right, so this is we're gonna express 3/4. 3/4 is a fraction to decimal, so meaning we're going to change 3/4 to decimal. So this is the process. Okay, so 3 divided by 4. 3 is our numerator and 4 is our denominator. So when we divide 3 by 4, of course 3 divided by 4 cannot be, so we put 0 here. So 0 times 4, that's 0. Okay, so the decimal point is here. Okay, 3 point. Okay, so we add 0. So we have 30 divided by 4, that's 7. 7 times 4, that's 28. So 30 minus 28, that's 2. 2 divided by 4 cannot be, so bring down 0. So 20 divided by 4, that's 5. 5 times 4, that's 20. 0. Okay. So in the division process, it shows that 3/4 is equal to 0.75, which is a terminating decimal. So meaning the value of 3/4 is equal to 0.75 in decimal. Next example. Example number 2, express 4/9 as decimal. Okay, so this is the usual process of dividing 4 by 9. 4 divided by 9 cannot be, so we put 0 in the as quotient. So 0 times 9, that's 0. So we add 0 here, so that's 40. 40 divided by 9, that's 4. So this is the decimal point. We will have to carry the decimal point in our quotient. So that's 0.4. 4 times 9, that's 36. 40 minus 36, that's the answer is 4. 4 divided by 9 cannot be, so we will bring down 0. So 40 divided by 9, that's 4. 4 times 9, 36. 40 minus 36 is 4. 4 divided by 9 cannot be, so bring down 0. That's 40 divided by 9, that's 4. 4 times 9 is 36. and 40 minus 30 is 4. Okay, so we have a remainder of 40. Okay, so I'm going to say as we go along, so when we add more zeros in our dividend, so the quotient, the digit 4, keeps on repeating. So this is an example of repeating decimal. Okay, repeating non-terminating decimal. So the quotient is repeating non-terminating decimal. We know that. The bar is used over the digits is called vinculum, this one. Okay, so we call this vinculum. The digits that repeats is called repeaten. Okay, 4 is repeaten. Okay, so you have to take note for that. The bar is used over the digits one is called vinculum. And the repeated digit, okay, in the quotient, okay, is called repeaten. Okay, all right. Example number 3, express 22/7 as decimal. All right, for the solution, this is the usual process. 22 is our dividend, and 7 is our divisor. When we divide 22 by 7, that's 3. 3 times 2 is 21. Okay, so to continue the process, we will get the quotient, which is equal to 3.142857, 142,857, 142,857, and so on and so forth. So meaning, the repeated digits are 142,857. That's why we have a vinculum for over the 142,857. All right. So 142,857, it means that the repeated is 142,857. Okay. So note, if fractions can be changed to decimal, then the decimal can also be changed to fraction. Okay, we have an example. All right, but before that, a terminating decimal can be changed to fraction the way it is being read. Okay, so I'm going to say all terminating decimals can be changed to fractions. Okay, all right, example number 1, change 0.55 to fraction. All right, so 0.55, okay, we have the solution. This is read as 55 hundredths or 55/100. So the fractional form of 0.55 is equal to 55/100. We will simplify, or we can reduce 55/100, okay, by dividing the numerator by 5. Okay, 55 divided by 5, so that's 11. 100 divided by 5 is equal to 20. So meaning to say, the fractional form of 0.55 is equal to 11/20. Okay, so in example number 2, change 1.345 to fraction. Okay, for the solution, this is read as 1 and 345 thousandths. Okay, 1 and 345 thousandths. So we can say that 1.345 is equal to 1 and 345/1000, or 1 and 345 thousandths. Okay, this is equal to, we will simplify, or we will reduce the 345/1000. Okay, so by 3, okay, no, by 5. Okay, so 345 divided by 5 is equal to 69, and 1000 divided by 5 is equal to 200. So 1.345 is equal to 1 and 69/200. Okay, now we will simplify, or we will convert mixed number to improper fraction. Okay, so what's the process? We will multiply the denominator, which is 200 to 1, and then added to the numerator, which is 69. So 200 times 1, that's 200 plus 69, that's 269 over the denominator, which is 200. To check if your answer is correct, you have to divide 269 over 200, and the quotient is equal to 1.345. So meaning the fractional form of 1.345 is equal to 269 over 200. All right? All right. So this is the final answer. A repeating decimal can be changed to fraction using simple algebraic method. Okay? So this time we will apply our knowledge in algebra. Okay, for example, this example number 3. Express 0.3333 dot and so on as fraction. Okay, so the solution, let x as 0.3333. So meaning to say, we will make two equations. Okay, for equation number 1, we will let x is equal to the given. X is equal to 0.3333 dot. And okay, notice that since the decimal repeats every one digit, multiply both sides by 10. Okay, so 333, so meaning the repetition happens in one digit. Okay, so one digit only. So we will multiply both sides of our first equation by 10 to generate the second equation. So when we multiply x by 10, so we have 10x. When we multiply 0.333 dot by 10, so that's equal to 3.3333 dot. Okay, all right. Next step, we are going to subtract the second equation from the first equation. Okay, so this one, no? The second equation is 10x minus 3.333 minus the first equation, which is 1x is equal to 0.3333. Okay, we will subtract 10x by 1x. So the answer is 9x. 3.3333 minus 0.3333, the difference is equal to 3. So we have now a new equation which is equal to 9x is equal to 3. Okay, our main purpose here is to find the value of x. So we will divide both sides by 9. We will divide this by 9. So this is now the result. X is equal to 3 over 9. Okay, 3 over 9 is reducible. Therefore, x is equal to 1/3. Okay, so to generalize, 0.3333 dot is equal to 1/3. Okay, the fractional form of this repeating but non-terminating decimal is equal to 1/3. You try solving this one using your calculator. So you divide 1 by 3. So the answer is 0.333 and so on and so forth. All right, so any question? Okay. Okay, this is the final answer. Now, number 4. Okay. For number 4, example number 4, express 0.1212 and so on and so forth. 12 as fraction. Okay. For the solution, since 12, the two digits 1 and 2 are repeating. Okay, so meaning to say, first process, we have to find or we have to generate equation number 1. So equation number 1 is the given. X is equal to 0.1212 because 0.1212, of course, we have a vinculum over 1 to 2 or 12. So I mean to say this is equal to 0.1212 and so on and so forth. So that's our equation number 1. Okay. Now we're going to multiply by 100 since the decimal repeats every 2 digits. Okay. Notice class, that's 0.12. Okay. So meaning there are 2 digits. So we're going to multiply both sides of an equation by 100. Okay, if it is 1 digit, you multiply by 10. If it is 2 digits, you multiply by 100. If it is 3 digits, you multiply both sides of equation number 1 by 1000. Okay, so now next subtract equation number 1 from equation number 2. Okay, this is our equation number 2. This is our equation number 1. So we will subtract 100x minus 1x. So that's 99x. Okay, equals 12.121212 minus 0.121212. Okay, the difference is equal to 12. Now, to eliminate this number or to find the value of x, we're going to multiply or to divide both sides of an equation by 99 to cancel 99. Okay, so 99x over 99 is equal to 12 over 99. So cancel 99. So x now is equal to 12 over 99. Now 12 over 99 is still reducible. So by dividing the numerator and denominators by 3. Okay, so 12 divided by 3 is equal to 4. 99 divided by 3 is equal to 33. Okay, this is now our final answer. So meaning the decimal 0.12121212 and so on and so forth is equal to 4 over 33. Okay, so we proved that a repeating but non-terminating decimals can be converted or can be changed to fraction. Okay, so that's example number 4. Let's go to example number 5. Express 1.525525 as fraction. Okay, you try to examine the given decimals. 1.525525. So meaning there are 3 digits. Okay, the repeated digits are 525. Okay, so first step for our solution is to generate equation number 1. So this is our equation number 1. X is equal to 1.525525 dot. So meaning continuous. And we have 3 repeated digits, 525. So meaning we will multiply both sides of an equation by 1000 to generate our equation number 2. Okay, so x times 1000, this is 1000x is equal to 1000 or 1.525525 multiplied by 1000. The answer is 1525.525 dot. Okay, so we will subtract. Okay, 1000x minus 1, that's 9999x. 1525.525 minus 1.525525 is equal to 1524. Okay, so meaning we will divide both sides of an equation by 999. Okay, to isolate x. So we have x now is 1524 divided by 9999. Okay, this is still reducible by dividing the numerator by 3 and the denominator by 3. So 1524 divided by 3, that's 508. 9999 divided by 3, that's 333. Okay, so meaning this is the fractional form of the given decimal numbers. The 1.525525 is equal to 508 over 333. Okay, so you can use your calculator to check if the two are equal. Okay, so any question? All right. Now, what are the 3 types of decimals? Okay, so can you give us an example of the 3 types of decimals? Okay, number 1 is terminating decimals. Okay, for the example of terminating decimals, we have 4.567, 0.11111176. These are example of terminating decimal. Now, another type of decimals, repeating non-terminating decimals. Repeating non-terminating decimals. So we have 0.199, dot. So meaning the 199, okay, these are the repeated digits, 199, okay, 199. Next, 2.45, 45, dot. So meaning the 45, okay, the two digits, 4 and 5, keeps on repeating. Next, 2.637. So meaning the repeated digits are 637, 637, 637. So this is now an example of repeating non-terminating decimals or non-terminating but repeating decimals. Okay. All right. So for non-repeating, non-terminating decimals, okay. So they think the non-repeating, non-terminating decimals can be converted to fractions. Okay. So the example of non-repeating, non-terminating decimals are 3.14, 15, 17, dot. Notice that there is no repetition of digits. Okay. No repetitions of digit or there is no pattern of repetition. So that's why we consider this as non-repeating, non-terminating. Okay. The other one is 36.1052345110 and so on and so forth. No sign of repetition of digits. So this is an example of non-repeating, non-terminating decimals. The only difference between repeating non-terminating decimals and non-repeating, non-terminating decimal is that the repeating non-terminating decimals can be changed to fractions. Okay, while the non-repeating, non-terminating decimals cannot be. Okay, so you cannot change this one to fraction. Okay, another one, 36 point, this one cannot be changed to fraction. Okay, only the repeating, non-terminating decimals. All right, so any question about our lesson? Okay, fractions and decimals. We know that terminating decimals can be converted to fraction. We know that repeating non-terminating decimals can be converted to fractions. And fractions can be converted to either terminating decimals or repeating non-terminating decimals. But in the case of non-repeating, non-terminating decimals, cannot be changed to fraction. Okay? Our assignment is we need to answer our skill booster 1.10 in our textbook. This is pages 66 to 67. You answer letter A to letter B. So all in all, we have 20 points. Okay, so I think that's clear. All right. So thank you so much. Okay. So guys, that concludes our discussion about fractions and decimal. It's a step-by-step guide. So if you have questions, don't hesitate to approach me in Messenger or in any social media for information. Bye. Thank you so much.